Hi everyone. In this video we're going to continue on with section 3.4, which is about the binomial distribution. The last time where we led off was calculating the binomial PMF by hand, where I give you an x, I'm finding the probability that x equals something, and then we use the PMF to do it. And for one single problem, the PMF is not so bad, but there's no nice CDF form that allows me to plug one number in and then get the calculation of the CDF out. I actually have to do just adding up the binomial PMFs. And that in itself is quite tedious. And so what we're going to turn to, I'm not going to keep you doing things by hand for long. Luckily, we have statistical software that does it for us. Okay, so what we're going to do is turn to software which calculates these probabilities instantaneously almost. And so we just need to sort of know how to use the software correctly. All right. We're going to use the same example that I used in my example before the your turn in the last video, which says, suppose I take 10 consecutive free throws. The probability that I make any single free throw is 75%, and then I'm going to ask a number of probability questions. And so I'm going to go back and forth between my slides and Minitab. So at this point, maybe you want to pause the video and try to open up Minitab. Certainly, you may have some trouble. If you do, contact me, and we'll work through it. Okay, but hopefully you can get Minitab up and running because it's going to be important for you to do the homework. So I'm going to change now to Minitab. Sorry, a Minitab, and I'm already doing stuff. Minitab looks like this. Now, I have a Mac, and so it's going to look different on a Mac than it does on a PC. And in fact, some of the actual the way that Minitab is set up and the way that you actually do these things are going to be a little bit different. And so now that we're in person, or at least for now, I'm going to also try to show it in class on a PC so that you can see both ways. But in the videos, you'll get roughly an idea of what you want. Okay, so Minitab looks like Excel, pretty much. Here you can plug in numbers, or you can input numbers into different rows and columns. That's actually not what we're going to work with right now. What we're going to do is to go up to the top, which hopefully you can see, or at least the top bar, which hopefully you'll be able to find out. And the sort of thing that I'm going to click on here is calc. So hopefully you can see up the top, I've got like file, edit, so on, those sort of things. And we want to click calculate, which brings up a drop-down menu. And what we want are probability distributions. It has a bunch of stuff there, but we're going to go down to probability distribution, and then it asks you what three things that you want, which of the three things. And it says cumulative probability. Okay, that is the CDF. And so we're going to use that a bunch here. But it also has inverse cumulative probability, which we really haven't learned about yet. But we will eventually. And then at the bottom here, it says probability density. And that's a bit misleading because probability density corresponds to continuous distributions, which are in the next chapter. Now we're working with probability mass, but it includes probability mass as well. So I'm going to click probability density, and we're going to try to answer the question that we did by hand previously, but now with Minitab. Okay, so I hit probability density, and it gives us this pop-up window and asks me a number of questions here. So first is, what's the input that we want? Are we going to input a single value, or did we put things in the Excel-looking thing? Do we want a column of values? We want a single value, and the value that I was interested in, what's the probability that I make 6 free throws? 6 free throws. So I plug in 6. This was at the end of the last video. And then it comes to the distribution. All right, and there are actually a bunch of distributions that Minitab has in it. we're going to learn about not all of them, but a lot of them. We're going to look up at the top, and there's binomial. Great. So we click on binomial, and then you'll notice these changed right here. So it was on something called a normal distribution, which we'll learn about, that had something and something. But now we're into the binomial, which we should recognize these two as the parameters. So here's where we input the parameters of the binomial distribution. And so it was number of trials is 10. Event probability is 0.75. Always put it in as a decimal, not a percentage. And so when we click OK, it's going to give us here binomial with n equals 10, p equals 0.75, and there's the probability. And so if you remember back, I wasn't so sure I did it correctly, but it turns out that I did. 14.6% or 0.146 is the probability for x equals 6. Okay, great. So it's that simple, almost instantaneously with Minitab, and we don't have to calculate any of those weird things. Now I'm going to go back to here, and I won't actually play it, but we can look at the 4 sort of questions that I was going to ask. So I still have the same setup, 10 consecutive free throws, 75% chance that I make each one. What's the probability that I make at least 4? Okay. At least 4 is 4, 5, 6, 7, 8, 9, and 10. That is 7 or 8 possibilities, and so I'd have to calculate that PMF 7 or 8 times and add them all together. It would take me, a whole 50-minute class probably to do that. It would take a long time. But at least 4, that's sort of like cumulative probability. And so we can go to calculate probability distributions, cumulative probability. Okay, so what kind of window does that give us here in Minitab? It's the same sort of window, but again, a single value there, and we can go to binomial again, number of trials, event probability. This is going to give us the CDF at a single point. And so we have to think critically about at least 4. How do we find that probability? Well, at least 4 is 4 and above. That's not what the CDF tells us. It tells us a number and then everything to the left or below. So what we want to do is to find at least 4, we need to do 1 minus at most 3. At least 4 is the same as 1 minus at most 3. And at most is the same as less than or equal to, which is the CDF. So the number that I need Minitab to calculate is at most 3. So I put in 3, trials 10, event probability 0.75. I click OK, and then you'll see that it changed up here. Probability that x is less than or equal to x, the CDF at 3 is 0.0035. And so to find a probability of at least 4, it would be 1 minus this, and so that would be 0.987 or something like that. Or 0.997. Not 0.987, 0.997. So that's at least 4. At most 5, if I go down to the next one, well, that's exactly cumulative probability. It keeps stuff there, so 5 calculates it. At most 5 would be 7.8%. 7.8%. What's the probability that I make between 4 and 8 inclusive? 4 and 8 inclusive. And so here we want, we're actually going to need to calculate two things. So if you remember back to the rule between 4 and 8 inclusive is actually going to be the CDF at 8 minus the CDF at 3. So it's the CDF at B minus the CDF at A minus 1. And so we want to calculate this at 8 and 3. And so you can go through and do single value for both 8 and 3, or what you could do is call this maybe my x values, 8 and then 3. Okay, 8 and 3. If I go to calculate probability distributions, cumulative probability, now instead of a single value, a column of values. And so when I click on values in, it's going to show me the column. So I want that column. Same binomial setup. And maybe I want to store those cumulative probabilities next to the x values. I click OK. There they are. Okay, 0.75, this minus this. And although we don't need to right now, you can find a way to actually find the difference of those two columns in here. Maybe it could be up in here. I haven't done that, honestly, a lot with Minitab, and so I would just, by myself, calculate the difference of those. So C2 row 1 minus C2 row 2. So that might be up here in the calculator. So store results in C3, expression C2 row 1 minus C2 row 2. Yeah, so I'll get myself down too much of a rabbit hole if I continue on here. But anyway, that's how you get these probabilities. And sorry about that. If we go back here, that's inclusive. Exclusive is going to be B minus 1, so 6 minus f of 3. F of 6 minus f of 3, and so I would do the same thing. Okay. Now, we'll go through 4. Certainly in class I can write these down if that was too fast talking through. And here's a your turn. Now you're flipping the fair coin again, not 5 times, but 20 times. And I want you to find these following probabilities. All right. And so before we finish up here, I want to show you one last thing. Section 3.3 was about calculating the mean and standard deviation of a binomial random variable. Okay. And so it turns out that for these name distributions, people have gone through, it's not hard, so they're like sort of fundamental to it, but you can go through and you can define a functional form for the mean, or a nice formula for the mean and variance or / standard deviation of a problem. And so for the binomial distribution, the mean is actually n times p, and the variance is n times p times 1 minus p. And the mean is actually quite intuitive. So if you said, I flip a coin, a fair coin 10 times, how many heads would I expect? And you would probably answer 5. Well, n is 10, p is 0.5, 10 times a half is 5. And so the mean sort of makes sense, or hopefully should. The variance is less intuitive about why it is what it is, but there it is. So these are nice formulas that you should remember. If I ask for the mean of a random variable, you don't have to go through and write out x times p of x for all of the x's. Like we learned in chapter 3, you can do a sort of a shortcut method.